Okay, so I'm going to move back on to encoding some more like floating point and SIMD sort of utility instructions. So I thought I'd start with AND. So we've got ANDPS NPD, and then we've got ANDNPS NPD. So I'll focus on these ones first. So we'll start with ANDPS. So we'll go to the encoder test here, and we'll do ANDPS. So ANDPS basically has the operand encoding RM for the legacy encoded version. So this is, we'll do XMM0 with XMM1, and then we'll do RCX as the memory one. So that's all that is for this one. Then moving on to the VEX encoding, we've got the same thing basically, but we've got an extra operand. So we'll add XMM1 into here and change this one to XMM2. But this supports a couple of different sizes, so we've got YMM here as well. So we'll just copy these tests here and do YMM. And then for the EVEX versions, we've got XMM, YMM, and ZMM, but I can use these op masks as a way to force the EVEX encoding, so I don't need to bother with like extended registers or anything. But these ones also support a memory broadcast as well. So we'll just make a copy of, let's say, this first one here, and if we put the op mask on it with zeroing, that will force the EVEX encoding already. But we need this additional test, which is the memory as a broadcast. So this is XMM with 32-bit elements. So this is going to be 1 to 4, because 32 bits will fit into the 128-bit element 4 times. So we'll just take a copy of this and change it to YMM. And because it's changing to YMM, that means that the broadcast will now go to 8 lanes. And then we'll do ZMM, which will change the broadcast to 16 lanes. So let's just run NASM and make sure it's all okay. Seems like it's fine. Let's just have a look at the listing. So here we've got EVEX encodings, we've got VEX encodings here, and we've got legacy encodings here. So we'll just take this over to the encoder test and put it at the top here. Okay, so comma, okay, this is the mnemonic. We'll start with just X word as the width. So we've got V0, V1, NA, but then these ones with, well, actually, let's sort out these 3 operand ones first. So from V1 here, we're going to go to V2 over there. This V1 is going to change to CX as a memory access. And then all of the other ones here are changing V2 to CX as a memory access. And then all of the ones where we have 1 to something need to be set as a broadcast. So this is where M needs to have B added onto it. And then all of these ones with the K1 need the first operand to have K as K1, and then Z for the zeroing mask as well. Okay, so I think that's all okay. We just need to change the widths now. So these ones are ZMM, these ones are YMM, and then these two here should be YMM as well. Okay, I think that's everything. So let's just go and, I guess, group these with the other sort of SIMD instructions. So we'll do this here, go to the forms table, we'll just add it up here as an empty table right now. So let's do the tests. So this is, oh, I need the V version as well. Okay, so now we can't match any instruction forms, which is fine. Okay, so let's go to the forms table. So here for the For the legacy encoding form, the width is just going to be X word, and the op-n for this is rm. So this is where op1 will be a vector, and op2 can be a vector or memory. Then we've got the secondary opcode map. So map is map0f, and the opcode is 54. So OX54. Then we can just take this form down into here. This will need to have a couple of different forms so that we can tell the Z word ones that it can accept the op mask, the zeroing, and the broadcast for the memory operand. So these ones are all going to be we're going to have X word and Y word for the VEX family. So this is family VEX. And this will be X word and Y word. And this is operand encoding RVM. So that needs to be RVM. Op1 is vector, op2 is also a vector. And then op3 can be a vector or memory. And this has the secondary opcode map with the same opcode again, so that's fine. And then we'll make a copy of this for evex, and evex allows us to do it the broadcast and the op masks for all of the sizes. So we can just add Z word into here. This is also RVM, so that's fine, but op1 can also accept an op mask and zeroing. And op3 can accept broadcast. So let's just do the test again. Okay, so that's fine. So let's move on to ANDPD, which looks like it's the same thing, it's just that we've doubled the element size. So if we just go and make a copy of these two, instead of PS, it's going to be PD. Then in the assembly, I can just take a copy of these tests and change the PS to PD. But because the element size has changed it to double, it now means that they can only go to half the number of lanes. So this has to go to 2, this has to go to 4, and this has to go to 8. Okay, so let's just regenerate that listing. And then in the encoder test, I can just take a copy of these and change the PS to PD. And I don't need to change lanes or anything here, because really that syntax, as I've said before, is purely for the programmer. You don't actually need to know the number of lanes. All you do is set a bit to say that you want to broadcast, and that's just, the number of lanes is fixed anyway, so really that syntax isn't actually needed. Okay, so let's just run these tests. So we're getting matches on everything, but obviously the incorrect output, because the forms are for the PS version. So these ones are, they look like they're the same, but they have the W bit set for evex, and they have a prefix of 66. So let's just go to the forms, and we'll change this so that they all have a prefix of 66. So we'll put prefix is prefix 66 in here, and then for evex, we also have W being set to W1. Okay, so that's fine. So now if we do ANDNPS and ANDNPD, these look like they are the same forms, but they're just different instructions, so different opcodes. 55 is the opcode for these. Other than that, it looks exactly the same to me. So I'll just make a copy of all of these. And we'll change AND to ANDN. Let's just go and add the mnemonics. So we've got AND, that needs to be ANDN. Let's go to the assembly. We'll just take a copy of all of these tests and add the N after the word AND here. Let's just go and try and regenerate that. That all looks okay. So the encoder test is just going to be a copy of these again, but with ANDN instead of just AND. Okay, let's do the test. This should match but get the incorrect bytes. So I just need to change the form to use 5.5 instead of 5.4. Okay, and that all passes. So that's the AND group done. Now there should be, I think, we'll do OR next. OR should be here. So we've got ORPS and ORPD. Again, exactly the same forms, exactly the same opcode, or the same op masks and things. So I think for this one, we'll just make a copy of these two. Okay, we'll change AND into OR. So we've got ORPS and ORPD, and both of those have V prefixed versions for VEX and EVEX. So let's just try regenerating the listing. Let's go to the tests and take these ones. We'll put them below here. This one is AND, oh, that's just ANDN. Okay, that's fine. Okay, we'll just put this one down here and change this to OR. So now I'll need to go and add the mnemonics. Okay, let's do go test. Okay, so it couldn't match any forms, that's fine. So let's just take all of these ones, put them down here, change these to OR. This should now output the incorrect bytes. So this is similar, there is no prefix, but it's 5.6. Yeah, okay, so no prefix for these, which looks like it's fine on here. So this needs to change. 5.4 now becomes 5.6. Okay, and we've got some incorrect stuff for the, oh, I've missed this one. That should be 5.6. Okay, that's all fine. So to go along with OR, there's also XOR. So we'll go and find XORPS here. Again, exactly the same forms again, so this is just another copy. We'll just copy these forms here. Change we'll change ORP to XORP. Then we'll go to the assembly, make a copy of these tests here, put X on them. Let's regenerate that listing, create an encoder test. So take a copy of these ones, add X onto the beginning. Okay, let's do a test. I need to do the mnemonics. Okay, so now the test is matching but outputting the incorrect bytes. So this one is 5.7. No prefixes, so that's okay. We'll just go and change the opcode from 5.6 to 5.7 instead. Okay, so now, so that's like the logic, like bitwise sort of ones. There's also things like MAXPS, so I suppose we'll go and do that. So we've actually got MAXSS and MAXPS. I think if we could do the scalar versions first. So here we've got MAXSS, and the forms for this are RM and then RVM again. So this one we'll do RM, XMM0, XMM1, and this one can be RCX as the memory access. Then we've got same thing but with V. And this one has the extra operand on the end, so XMM2 along with the memory access, and then we have another one where this one is EVEX that allows the masks, and this one also allows SAE, so let's try and put SAE on here. Oh, this should be on the this one up here. Okay, I think that's all okay. We'll take this over to the encoder test, put it under here. So these are all X word. There isn't any other thing because it's a scalar single precision thing, so they're all just X word. So we've got V0, V1, NA, NA. Then these ones down here also include V2. This one changes to CX with a memory access. These two are CX with memory access. Then this one actually has SAE on it. And both of these have K1 along with Z. So I think that's all of those done. While we're here, I suppose, well, let's just get this one working first. Okay, so we'll just go to here and put the mnemonic in. So we've got MAXSS, MAXSS form. I need VMAXSS as well. Okay, so now we get some incorrect stuff. I don't need these sizes, these extra sizes here. For the vector, for the operand 1, it does support mask and zeroing, but there's no broadcast on this. Instead, this is SAE. And then the rest of it is just changing. So these ones have a prefix F3. Going with map 0F, which is fine, and then we've got 5F as the opcode. And this one should be, oh, I've changed the wrong one. This one should be 5F. But there's no W set on this one. Yeah, that seems like it's okay. Okay, so now if we just copy these for the SD version, so scalar double precision. We'll just go and copy these mnemonics. So we've got SD, ASM, we'll just copy these ones and change it to SD. But usually with SD, okay, we've just got suppress all exceptions on this one as well, so that's fine. So for this one, we need to do the encoder tests as well. Okay, so here we've got a prefix of F2. So we'll just go and change that prefix from F3 to F2. Okay, and now we've got MAXSD is incorrect. This is probably because the W bit needs to be set because it's a 64-bit element size. Okay, so that's fine. So that was Max for the scalar version, and now the packed version we also need. So this one is the same as the other tests, but it allows for SAE in addition to the broadcast on the Z-word version. The rest of it looks like it's the same as the other tests. So let's just go and take this XOR test. And instead of XOR, this will now be MAX. But for the Z word, we have memory broadcast, but we also have SAE on here. So we'll put SAE on both of these. And actually, I'll just check. PD sometimes changes to ER, but this one is staying as SAE, so that's fine. So let's just regenerate and check. I think that's all okay. Okay, so with these ones, I'll take these XOR tests, put them down here, change XOR to MAX. And then for these Z-word tests here, we're going to have SAE on the register version. And then I'll just need the mnemonics as well. So instead of SS, this is now PS and PD. This one's PS, this one's PS, and then both of these ones are PD. Okay, let's go to the forms table. We'll just take all of these XOR ones here, put them below here, change the XOR to MAX. But the Z-word version also needs to allow for SAE. So we'll take Z-word off of this form here and just put Z-word as its own independent form. That's PD. This one also needs to do the same thing. So we'll take Z-word off of here, keep it as its own independent form, and on the Z-word one, we'll allow SAE. Okay, so MAXPS is 5F with no prefix. So there's no prefix on these. This one is 5F. I assume that this one is the same opcode, but this one's got a prefix of 66, so that's all looking okay. Okay, that's fine. So that was MAX. Then to go with MAX, there's obviously MIN as well. So this is going to be more of the same by the looks of it. They've all got SAE and op masks and things. The SAE for the packed version is only on the Z word. So this can literally just be a copy of MAX. But we change it to MIN instead. Oh, and I need the SS and SD versions as well. So let's just go and create these mnemonics. And then we'll just take a copy of all of these tests and change max to min. I missed some of the tests. Oh, no, I didn't. That's fine. Okay, we'll just change these ones to min. Regenerate the listing again. Go to the encoder test. Let's get max tests. Make a copy. Change max to min. Okay. So go test. This should produce the incorrect bytes. So now for min, we've got 5D, 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 5D. So it's 5D for all of them. Yeah, okay. Looks like I just need to change it to 5D then. Okay, so that's fine for min and max. Next one will be square root. So let's go find square root. We'll start with SS again. These ones have ER on all of them. But other than that, it's the same shape really as min and max. So let's just go to the assembly test first. We'll make a copy of this min one. And we'll change this to square root. So yeah, we've got SSSD PSPD. So this is square root. Let's try the NASM thing. Okay, invalid combination. Oh, of course, this one has, let me just see. Invalid combination. So unsupported decorator is because it's ER now. So these ones should change to, what was it, RNSAE for round nearest, I think it was. So let's just redo that. So invalid combination of opcode and operands. So for a square root PS, let's just go and look at this. Square root PS, oh yeah, okay, these ones don't have 3 operands, whereas the other one did. Okay, so let's just get rid of some of these operands. We'll just get rid of this one for those. Then for any place where we've got like a 2 on the end, we'll get rid of those. This one has too many. This one also has too many. We'll keep it as 0, 1. So we'll just get rid of these ones here. This one's got broadcast, so that's fine. This one's got too many here. So 2, 2, okay, this one can go, that one can go. These ones can, well, so this one I'll get rid of the 2. These 2 can go, and these 2 can go. Okay, so that's all okay now. I need to change to square root still for these ones. So these are still min, so there should be square root now. Okay, so let's just go to the encoder test. We'll take this min one still, but I'll just have to change the operands a bit. So first of all, instead of min, this is now square root, which I'll go and add the mnemonics for. And yeah, okay, we'll just keep that there like that. So the tests for this now are that anywhere that I've got v2 with a v1 like this, I just need to get rid of the v2. So v2 becomes NA, and in any place where it's got SAE, I'll move the SAE onto the v1. Then for square root, if I've got memory access next to a v1, then these ones need to get come off. and we need to add NA. I think that is all okay. So let's just go and copy the forms as well. Square roots. And none of these square roots have op3 anymore. So anywhere that I've got op3 here, that needs to become op2. Like this. And instead of SAE, this should be ER instead. Okay, so square root SS, and then it can't find instruction form for the other one here. So this one is, so V square root can have YMM and everything as well. Yeah, okay, so V square root SS. This one is only X word, so that's fine. Also, this operand encoding should change to not have the V in it anymore. So it's saying it can't find a form. Oh, I've got too many operands in this one. This one should also not have this many operands. I don't know why NASM let me do that. Okay, so square root here. Oh no, this one does have 3 operands. It's just the PS and PD versions that don't have 3 operands. Okay, so I've actually got incorrect encoder tests for these ones here. This one should actually have V2. Oh no, this is, yeah, this is okay. Oh, it's not quite okay. Yeah, okay, so this one should be V2 here. This one should also be V2. Then we've got, so that's V1. From here we need V1. And here needs V1 as well. So 262. This one needs to have the NA taken off of it. Okay, and then it's just the forms to sort out. So these forms, this SS one, when it gets to the V version here, actually does take an op2, which can be VEC. And in this case, it is RVM. Yeah, RVM for these ones, which means these two down here need to be RVM. And this should be op3, this one should be op2, is VEC. Then this one has op2, VEC mem, this one should be op2, is VEC, and then this one is op3. This one is also op3, and op2 is VEC. Then we've got op2, this one is op3, has VEC or memory. Then I think the rest of them are okay. So we've got OP3. This one shouldn't have it. This one is still RM. Okay. That one's 2. Okay, let's try this. What's this? Duplicate field op2 on 621. Yeah, this one should be op3. That should be vec or memory. Oh, okay, I've already got this one. Okay, let's get rid of that. Okay, so could not match for v square root SS still. V square root SS, X word, vec, vec, vec. This one needs a V2 here. Okay. So now it's this one with the rounding. So that's because these rounding. So this SAE now needs to change to ER with RN. Then we've got V square root SD, which can't find a form now. V square root SD has the correct, it's got vec, vec, vec mem. So maybe this is a test problem. Yeah, this one should be V2 then, V1. Oh no, that one's correct. V square root SD. This one should be V2. Okay, so we're getting matching forms for all of them now. So now it's just the encodings. So for square root SS, we've got a prefix of F3. Which is correct. Then we've got the secondary opcode map, and then we've got 5.1. So let's just change all of these to 5.1 for now. Okay, and that makes them all pass. That's square root. The other ones are going to be the, so we've got RS, where is it? It's RCPPS. So this is the reciprocals of the packed single precision floating point values. And then there's also this, where is it? Reciprocal square root PS and SS down here as well. I think that's the main ones. So we've got RCPPS first. Let's just put the tests below the square root ones here. So RCPPS is, there's only one operand encoding here, which is RM. And they're all X word or Y word. So there's no evex here, this is vex only. So this one would do xmem0 with xmem1, and then RCX as a memory access. And then we've got the V version as well. So the V version is just the same thing, just encoded as vex instead. And then we've got the YMM version. And then we've also got SS here, which I'll actually just put above the PS one. So SS is, we've got RM and then RVM as the encodings. So for this one, that is already okay. And then we've got the V prefix version, which takes 3 operands. So this one has XMM2, and in the middle we'll put XMM1. So that's all okay for those tests, I think. And then it's, let's just go and look at the reciprocal square root one down here. So this one is the same shape, so let's just copy these ones. And instead of RCP, this will be reciprocal square root. Let's just generate these things. Okay, so the listing generates fine, so let's just take these tests over to Encoder test. And we'll put these below the square root. So let's just do these ones first. Okay, so we've got the mnemonic, RCPSS, with X word, because it's the only size. This one is V0, V1, NA, NA. This one is CX as memory. And then this one has V0, V1, V2, and CX as memory access. Then we've got the same sort of stuff down here, but a little bit different with the VEX encodings. So these ones are all X word as well. So we'll do V0, V1, NA, NA again. This one is CX with memory. This one is CX with memory. And same goes for this one. And then this one is V2. This one should have V. This one should have an extra operand, so this should be XMM2. Yep, this should be XMM1, and this should be YMM2. That one looks okay. Oh no, did this one have only 2? Because it's the PAX version. Okay, the PAX version is actually fine. So the PAX version here only has 2 operands, so that's actually okay. So the PAX version only having 2 operands for all of them is okay, so I can get rid of those. So this one becomes CX, this one also becomes CXM. The scalar version had the 3 operands. So let's just take a copy of these and move them down to here. So reciprocal square root is basically the same sort of thing, where we've got the scalar version has 3 operands for the VEX encoding, but the PAX version only has 2 operands. Okay, and then I've got a syntax error somewhere here. I need a comma on the end of these. Okay. Right, let's just get rid of these comments. And we'll take all of these mnemonics, deduplicate them, and then we'll add some empty form tables for them. Okay, so now if I run the tests, we basically just get the cannot match instruction form again, so that's fine. So we'll go to RCPSS first. So RCPSS, we're matching on a width of X word. OpN here is just RM. OP1 can be vec, and then OP2 can be vec or memory. This has a prefix, so we've got prefix is F3. Map is the secondary one, and then the opcode is 5.3. Then for the VEX family, we've got the same width and everything, but this one allows for 3 operands, so this is RVM operand encoding. And so OP2 is just a vector, whereas OP3 can be the vec or memory. And this is exactly the same encoding stuff here. Okay, I think that's about it for that one. Let's go and look at the PS version. So PS only has 2 operands for all of them. This one is no prefix. Has the secondary opcode map, and the opcode is still 5.3. But this one, for the family VEX, supports Y word as well. Then let's just go and look at the reciprocal square root. And that looks basically the same, so we'll just take all of these, move them over here, and change RCP to R square root. Then for the square root ones, it's basically, there's F3, 5.2, so let's just change this to 5.2. Okay, so VRCPS is has the incorrect encoding. So what's the encoding for PS? This is map 0F with opcode 5.3. That looks correct. Oh, this is probably an encoder test thing where I haven't updated the size. So these two here need to be Y word. And then the same would go for these two down here, should be Y word. Okay, that's all I wanted to do for now.